Hi roboticist, welcome back in this new video where we are going to spawn our pick and place application that we have seen in the last video in Rviz. We are going to spawn in a real world or better in a simulation environment like Gazebo. And I've seen that you tried already to make this happen by your own, but I have seen that a lot of you has faced a lot of problem during the interface between the Rviz environment, or better the MoveIt in Rviz environment, and the simulation in Gazebo. And this is why this interface I would say is not so easy at all. So I've decided to make this video to help you out in this. If you remember, I have done some times ago a similar video, but since that now we are dealing with some let's say relative complex application in a pick and place, I'm gonna to do it again from scratch, so in such a way that you can you can follow me step by step during this procedure. But don't worry, I'm gonna provide the link of the last video in the description down below. So before to start, make sure to subscribe to the channel, hit the notification bell, and if you want to have a deep dive into the ROS robotics application, you can check out my ROS course for beginners. There are a lot of videos. This is from beginner, and that will bring you to an intermediate level, so it's a good starting point. So now let's get started. First of all, what we can do is to create another MoveIt package from scratch with our cobot robot. So let's open a terminal, and let's type ROS launch, then MoveIt setup assistant, then setup assistant. Okay. So I'm going fast because it's a replication of what we have seen so far. Okay, it's just to have to give you a good procedure. So we can create a new file, so we need to give the URDF file. So I'm gonna go here. So in your case will be your chakra file. Okay, the robot it's spawned, then cell collision, generate the collision matrix, virtual join, we don't need it. So this is the first part. So here what we need to do is to associate a planning group for the arm, so let's call it arm. Then we can give a kinematics solver, and then what you can do is to add a joint, and then these are all the links that are associated, let's say, with the arm. Okay, so then let's save it. Then we can add another group. Now let's call it hands, and then what we can do, we don't need a kinematic solver, because this will be only given by the two grippers, so it will be a position controller. So we are gonna set up only open and close, so very simple, so we don't need a kinematic solver like this. So let's put it none, and then in this time we can add the links, and the links that we need to add is the gripper left and the gripper right. Okay, so that's all for the planning group. Then we need to set up the robot pose, so we can say that this position will be the 0 position, and then we're gonna save. Then we can add a pose, no, sorry, with the arm. Let's say that this one will be the home one. Okay, till now very easy. So now we need to set up an end effector, so let's call it hand, and then the group name will be the one that we had defined before, and the parallel link is the gripper connector. So, and I remember that based to my VRDF file, the gripper connector is this one. Okay, and the end effector, as I set up here, the hand is only the grippers, so don't make any confusion from that. Okay, so it's very important. Then save. Passive joint, we don't have it, so then we can add some controller. Don't worry about that, we are going to modify later on. This is gonna be ARM controller, so this will be a position controller. Okay, and then we need to add this. Okay, then we need to add other controller for the grippers. We can say gripper controllers, then this will be position controllers, and then we associate to the hand. Okay, simulation, 3D perception. We are not going to use this, but for the moment let's set up this one. Okay, it's done. Okay, so first let's have a check. Okay, so this is our robots. So the arm is composed by this joint base link link 1 till the gripper joint, and the planning group hand is composed only with the gripper right and the gripper left. That is taking this kind of position here. So from here nothing new, so let's try to make our pick and place application. So the same thing that we did last time. So we are gonna run ROS run, then cobot test, then pick and place node pick and place, I don't remember. Pick and place cobots nodes. Okay, now everything should be fine. So it's going to here, then it's going to grasp, and then when it's grasped, it's changing color, and then goes to the place position. Okay, till now nothing new. Okay, so now what we're gonna do is to refresh how to update our MoveIt package and the cobot simulation package in order to make a good interface between the MoveIt package and the Gazebo world, where in between we are gonna run our C++ code of a pick and place application. So first of all, let's open Visual Studio Code, and first of all I'm gonna go to our Cobot MoveIt Gazebo configuration package that we have just created, and let's go to config and let's modify this. This is the first step, so modify the ROS controller YOM file. Okay, this is something that has been created automatically, but if you're gonna spawn this, well, it's not gonna work. I'm not want to explain you why, so for the moment just trust me and comment this out, and then we are gonna create our another controller here. So let's create our joint state controller. Okay, then we are going to set a controller list. Then we are gonna have we are gonna set up the namespace, which is gonna be cobots, and then ARM controller. Okay, so this type of controller will belong to the action namespace, which is going to be follow joint trajectory. Okay, then default setup as true. This type of controller will be of type follow joint trajectory. Okay, and here, what are the joints that are belonging to this controller? So they will be the same that are associated to the ARM, which is gonna be this one. So let's copy and paste. Okay, and basically we will need to do the same for the gripper controller. So we are going to call it gripper controller. Here will be the same, and the joint, guess what? We have only the gripper left and the gripper right. So let's put it before right and then the left. Okay, This is the ROS controller configuration file belonging to the MoveIt package that we have set up with the MoveIt setup assistant that we need to be modified. This is the first file. Then we have the second file, I remember you, and we need to create another file inside the launch directory, and we are gonna call it Cobot MoveIt controller manager. Okay, so the ROS parameter will log the file ROS controller that we have just created here. Okay, we are done with the modification of the file of our MoveIt package. Okay, so now we need to update the configuration file of our Cobot simulation package, where I remember there's the URDF file and the launch file that we have created in all the video before. I'm gonna put the link in the description down below, where we have started this package. So what we need to do, we need to create other file that is gonna be Cobot joint state, okay, like we did the last time. So this is easy. And then we need to create another file that is called trajectory control YOM file. Okay, well, we are going to set up the type of the controller that we want for the arm control and the gripper controller. Okay, make sure to just copy and paste this, because it belongs to the Cobot namespace. And here we are setting up some parameters that are belonging to the joint trajectory controller action, here and here. Okay, so the last thing that you need to do is to create a launch file, or better, we have created our Cobot bring up MoveIt launch, and since that this is important, let's create another one and do it together, and let's call it Cobot bring up MoveIt gazebo.launch file. Okay, let's do it together from scratch. So first of all, let's associate the ROS parameter robot description to the chakra file that we have created. Again, here I'm gonna put the link in the description down below. Let's close this tag here. Okay, and now let's set the empty word. Here nothing new. We just need to create an empty word. For the moment we're gonna spawn the robot in an empty word. In the next video we are gonna create actually a word that replicates the environment that we have, or better the scene that we have set up in the Rviz simulation. Okay, so here we spawn the robots in the argument x, y, and z that we have set up here. And now something very important, that we need to spawn our controller manager, or better, we need to ask the controller manager to spawn the controller that we have set up in the trajectory control YOM file. And here we go. we have to use the controller manager package. Then we need to set up the namespace cobots, and then we have as an argument the joint state controller, arm controller, and the gripper controller that are exactly this one here. Okay, and then we need to load the controller here. And here we go. We have to remap the joint state to the namespace cobot and do the same for the joint state publisher. And then we need to launch this file here, planning context, move group, and the MoveIt Rviz that are belonging to the package that we have just created, that are here basically. Okay, this is done. So last thing what we need to do is to update the C++ file that we have created in the last video. So I remember you that is going to be in the cobot test package, a source file, and this one. So you can say that last time we have used this file. So what we need to do now, basically the pick and place and the add collision object and the main are equal. So basically what we need to update is the open gripper function and the close gripper function, and this is why, because despite the fact that is a mimic joint, the gripper left joint, in Gazebo it doesn't take care of it. We need to associate some kind of controller, even if it's going to mimic. Okay, so that's why we need to resize the joint name to gripper right joint and gripper left joint, and then set up the position and for both joints, for both grippers. And I remember you that for the way that I have set up my URDF file, my robot has the gripper when it's open, both joints are 0, and when it's going to close, the gripper right has the position on 0.05 and gripper left has the position in minus 0.05. Okay, and as I remember the pick will be the same. So basically if you wanna see better, you can check out the link in the description down below. Basically it's the last video that I made. Okay, everything should be set it up correctly. So as a recap, we have created our MoveIt configuration package, and we have updated the ROS controller YOM file. Then we have created the cobot MoveIt controller manager file. Okay, then we switched to our cobot simulation package, and we have created our trajectory control YOM file, where we have set up the arm controller and the gripper controller as belonging to the position controller and the joy trajectory controller type of controller, of course. And then we have updated our launch file, where we have updated our controller manager to our controllers that we have configured before. And then last, we have updated our pick and place C++ code, and in particular the open gripper and the close gripper functions. Okay, basically everything should be good. So let's build the package. And test it out. So first of all, let's launch this Cobalt Brigand MoveIt Gazebo .launch file. Okay, here I did a mistake, so let's run it again. Okay, this is our robot. Let's press play, and then Rviz should be open automatically. Okay, so here we have our robots, and we can see here that for example, if we set up the goal state at the home, which is gonna be here, and we plan and execute, then the robot is going to reach the position. So meaning that the ROS controller, the controller of our joint are working in our environments. So let's wait that the robot reaches the position. So don't worry if it's gonna be slow, it's normal. We can tune the joint later on, but for the moment we just need to understand how to make a certain movement in a simulation environment. Okay. Okay, this is executed. Okay, what we can do now is to run the pick and place code the scene, and here we go. You can see that is going to approaching, the gripper are closed, the pieces is taken, and then it will go to the place position. This is the planning behavior. and this is the actual value of the joint that is simultaneously synchronized with the word gazebo. And then the grippers are opened. Okay, so very easy. So we can do it again and then run it again, and then the robot will start from this position and will do another plan to reach the pick position. So what will be so this is failed, so let's try it again. Okay, now the robot is going to the pick position from the position that we have set up before, and then is going to pick the object. Of course, now there's no object, but we're gonna create our word in the next video. So we have approached, we grasp by closing the grippers, and then we go to the place position. Okay, we run our C++ code, and the environment has been created, and the Rviz is making this word, and simultaneously you can see that the robot is reaching the pick position. He's approaching with the pre-grasp approach, then close the gripper, okay, and then it will go to the place position, and you can see here that this is the planning, and this one will be the actual position. Then it goes down, open the gripper and retrieve this, and the application is finished. The robot in a real world, or better in the simulation environment, has performed correctly the pick and place application. Okay, I know that you are thinking that it's not completed because there's any word here, there's no object, there's no table, etc. But this is something that we are going to do in the next video, where we are going to update this launch file, and we are gonna create a word that is replicating the one that we have created in the current scene, table 1, table 2, and the object, and we are gonna check if this simulation will be able to actually pick and place an object in a simulated environment like a gazebo. That's all for today. Thank you for your attention. If you like this video, make sure to subscribe to the channel and hit the notification bell to do not miss the next topic, which will gonna be very interesting. And if you wanna master your career and being a robotics software engineer, let's start your journey by checking out my beginner ROS course. I'm gonna put the link in the description down below. Again, thanks for your attention, and as always, keep learning robotics with ROS.